Good morning, good afternoon, good evening, wherever you may be in the world. Welcome to today's webinar from Solibri, Building a Fire Safe Future. My name's Andrew Bellerby. I'm the Managing Director for Solibri in the UK, and I'll be your host for today. Hopefully you can all hear me okay. So I'm very aware that there's probably a few people on the webinar that perhaps are attending for the first time. So just to give you a little bit of insight into Solibri. Solibri is the leader in BIM quality assurance and quality control, providing tools that allow you to run rules for compliance checks, building control, design coordination, design review, and various other checks using logical rule sets. What you'll see today is some of that a little bit later on. We are actually going to start with a couple of industry speakers first. So once I've done the introductions, we're fortunate to have Dr. David Hancock from the Infrastructure Projects Authority joining us, Alex Plenty from one of our customers, Region Partners, and then a little bit later on, Simon is going to show you a live demonstration of some of the fire safety options that are in Solibri and some new developments that we've got. In terms of questions and answers, if you post your questions in the chat, then we will address them at the end. And if there's any that we don't answer, we will respond afterwards. The webinar is being recorded and will be available on our website afterwards. So first of all, I'm going to run a couple of polls just to understand the audience a little bit better. So I'm going to, first of all, just ask the first question. Let me make sure we can do that. At what stage of the project do your fire safety coordination and you do your fire safety coordination and checks? So the poll hopefully is visible shortly. And if you can tick in there, and we'll see what responses get. Hopefully not too many as an afterthought, but let's see. Okay, so that's going up. It's good to see that it's done as soon as possible in many cases, or certainly during the design coordination. We'll let that go for a few more seconds. And maybe we can show those that have put as an afterthought how they can do things a little bit differently going forward. Okay, I'll close that poll in a second. And then we'll move on to the second poll. Who in your organization checks the digital model for compliance and for fire stopping? So let's close that poll. And if we go to our second poll, just bear with me a second. Oops. Okay, polls, find the next one. Okay, I'll run the second poll a little bit later after the presentations, once I've figured out how to move on to the next poll. Okay, so our first speaker today, our first keynote, as I mentioned, is Dr. David Hancock from the Infrastructure Projects Authority, where he's the construction director. David is a chartered engineer and the construction director at the Cabinet Office, providing construction and project support to secretaries of state, ministers and all government departments, a high-risk projects reviewer across government and a graduate of the Major Projects Leadership Academy, He leads the government construction community and sits on a variety of across-government boards, including cladding remediation, new prisons programme, Buckingham Palace refurbishment, British Antarctic Survey, which a very lovely picture from the Antarctic there, and he's also the non-executive chair of Syria. Prior to this, from 2009 to 2016, he was head of PMO and risk for TfL. He's renowned internationally as a leading author and practitioner in the field of behavioural risk. He's worked across public, private and voluntary sectors and was the risk director for the Terminal 5 project at Heathrow. Now, I'm going to show David's presentation. Unfortunately, he can't share them himself due to limitations of security on David's laptop, but hopefully all goes well, and I'll hand over to David.
Thank you, Andrew. And while you get the slides up, I'm delighted to be here, and especially this subject's really close to my heart. I've been involved in Grenfell right from the 14th of June 2017, where the fire took place. I also sit on the CLC, Building Safety Group, Government Construction Board, and I chair the Government Construction Community. I sit on the Playbook Oversight Group, which is looking at building safety, and sit on the Building Safety Working Group. And I'm also a co-chair of the Industry Response Group, which was the response to Grenfell. So this subject is really close to my heart. Have you got the slides up, Andrew?
Yes, they're good to know.
Okay, I can't see them.
Okay, let me just check.
So I know what's in them, but
Sorry. Okay, so apparently the poll is still just bear with me a second and I will get that all working again.
So yeah, I can see the poll.
You'll have to excuse me, this is my first time running a poll. Let me just see how we close that.
That's it, thank you.
You see now?
Just need to put it into presentation mode. That's click on the little.
Yeah, okay. Is that working?
I don't know anybody else. That's it. Okay. I can see.
So now we have it, yeah. Apologies for that.
That's all right, Andrew. Next slide, please. So I'm going to talk about the golden thread. You're probably aware that Dame Judith Hackett did a report on building safety following the Grenfell fire, in which she recommended the introduction of a golden thread to support duty holders when designing, constructing and managing their buildings. And the government, as a government, we've committed to implementing all of Dame Judith Hackett's recommendations on the golden thread, but most of them in the Building Safety Future report that you see there. Next slide. In order to do that, we've got a building safety bill that's going through government. It's just finished in the House of Lords and coming back to us. But within that, there is a whole load of clauses that we put in that mandates the use of a golden thread in place for buildings of a new stringent regime for design, construction and refurbishment. And the new gateway process, and each area you'll see that there is a level of information that has to be provided within that document. It also details the contents of the golden thread, how it should be stored, managed and set out. And the other ones that are relevant to it are, it requires an accountable person, so a level of competency, and gives power of requirements to be handed over to the various people as it goes through, similar to those CDM regulations that most of you will be familiar with. Next slide. So this, I'm not going to go through this in detail, but this shows you what information is going to be required in order to meet the golden thread and to be able for us to identify and understand and mitigate fire and structural safety risks throughout the life cycle of the building. So that's right from conception all the way through to disposal. And more importantly, it also talks about occupation and what is required and access that the residents of the building will be able to have access to it, to understand what is being held and what level of risk, if you like, that they are open to and what they can expect in their building, so that residents can feel comfortable that they are living in safe buildings. Next slide. This one here just gives you a high level. We had a working group, and in July 2021, it says that the data must be accurate and trusted, a single source of truth, secure, understandable and consistent. And by understandable, we mean to a layperson, not just those experts in the field. Simple to access, longevity and shareability of information, relevant and proportionate, and accountable. So people will put their names and signatures to this. We're expecting photographs of as built against the as designed, because what we're finding is, as we're taking off some of the cladding of some of the buildings, that things that should be there are not there. Things like fire stopping put in the wrong way round, or not in there at all, or not the right level. So this will start to give an accountability through those people and through the organizations for building buildings as the residents should expect them to be built. Next slide. One of the areas that we have released recently, and I commend you to go and look at it, is what we're calling the construction playbook. And part of the construction playbook that we're working on at the moment will have the statutory gateway approvals in it for defined interventions, rigorous inspection. One of the things we're also seeing is that maybe inspections have not been quite as rigorous in the past as they should have been, but also that having done those inspections, that there is a record of it, who did it and what they did, all the way through planning, design, construction and operation. And the construction playbook is the way we will source and contract on public works. Next slide. The other thing was released just recently is guidance on collaborative procurement for construction to support building safety, written by David Mosey of King's College, taken on board, and it really is quite an exciting area of what frameworks and how we're looking to set up frameworks across the projects we're running in government. And within it, in section 8, it talks about a golden thread of information that integrates design, construction and operation, and that all key information related to fire and structural safety will be submitted during 3 gateways, which will form part of the golden thread of data, and that is made accessible to relevant people throughout the life cycle of the building. And that there'll be a need to monitor and update the golden thread. So if you do refurbishment changes, any modifications on the building, we will expect it to be modified and kept up to date and accurate. And the use of digital to integrate those designs, construction and operation. We believe the only way that you're probably going to be able to meet the requirements is to use some kind of digital methodology. Next slide. That's the technology. We'll talk about technology, regulations. You can see how the whole of government industry, this has not been written just by government, but it's been jointly with intervention and involvement of industry, and hundreds of meetings with tier 1, tier 2 and tier 3 suppliers in order to get to this. But we also realize that we can't just do this on legislation and technology, that there will need to be some behavioural changes taking part. Amanda Long who leads the Considerate Constructors, which I'm sure you're all familiar with, is leading a charter called the Building a Safer Future. And within that, the people who sign up to the charter will make these 5 commitments. And it goes beyond statutory requirements. It says that what you need to do is actually believe in this and look at it holistically, and that they'll collaborate across the industry to spearhead culture change, and that those people will be the voice of building safety across the sector. One of the things we've found, and if you listen to the Grenfell podcast on the BBC, they do one every Friday. It's a sum up of the week of what's happening at the moment. The housing ministry is up in front of the board, in front of the committee at the moment, but they'll actually will call things out that are not right. And we need to do this. The Grenfell has shown us that people were aware of it, but didn't call it out. So one of the behavioural changes that we will call it out, that will be transparent in our interests, sharing information with residents, clients, contractors. And one of the things that was said to me was, you are safer building one of these buildings with all the move forward we've done in health and safety than you are actually living in it, which is a really kind of sobering thought, to think that because of all the changes we've done in the industry towards health and safety, that actual fact they're in a better condition than they are for the people living in it. Ensure that the voices of residents, visitors, employees, fire brigade who have to come and put out a fire should occur, there is a voice that they have, that they're listened to as well. And then set out the communications, clear responsibilities within your organizations, partners, ensuring that everybody has a stake in this during design, construction and occupancy. So each person understands their role, what their responsibilities are, and what their commitment is when they build these buildings, and that they take the time and resources to achieve and maintain building safety. That's the end of my presentation, Andrew. Hopefully that's giving you a flavour of where government and industry are coming from.
Yeah, thank you, Dave. That's a great overview, and I think it shows the importance of golden thread and the transparency that is going to bring to the industry, and what it means to hopefully everybody who's on the webinar today. Just before I move to the next speaker, I'm just going to share the results of the previous question. Now that I know how to operate the polls in GoToMeeting. So you can see there that the bulk of people do their fire safety checks as part of the design coordination, but a good 40% are doing that as early as possible in the process, which is good to see. Okay, we'll carry on with our presentations. So if I hide that again, and we'll move on to Alex. I'll make you the presenter, Alex.
Am I showing the right screen?
Actually,
okay, I think it's that one. Is that right?
yes.
Cool. Thank you, Andrew. And thank you, David. It's going to be tough to follow that presentation, but I'll do my best. So fire stopping, checking with Solibri. So my name is Alex Plenty. I work for Ridge & Partners. We're a multidisciplinary construction property firm, and we've got a building information modelling team, which I'm a part of. And my colleague Brent, who normally does double act with me on these slides, can't be here today, so hopefully I'll do his slides justice. So using digital technology to make the right decisions. So good decisions are based on information. Bad decisions tend to be based on feeling, opinion, so information is to inform. And as it helps us answer plain language questions. So our clients have questions like, how safe is our building? How environmentally friendly is our building? And it's up to us to present data in a way where we can swap out different products, give them different choices, and to try and query data to answer their questions. Information should be made up of good data. A lot of people talk about good data. I could probably put maybe 100 bullet points of what's good data and what's good bad data, but I've just picked 3 main ones. So about data structure, in the BIM world, we put things on common data environments to upload things, and that's a structure. Information models should be structured as per IFC. And you'll see later in the presentation that's sort of key when we're doing these fire stopping checks within Solibri, that we're structuring data in a consistent way. You need to think about who's best to provide the data. So something like a fire rating might be provided early on in the design by an architect who might be with some help providing the fire strategy for the building. But in terms of product data, sometimes that's specified early, and then there's linked to a product might be specified, and then there might be a procurement decision in terms of when it goes to contractor, that product might change. And then there might even be an installation decision. So even if it gets to site, that might be swapped at the 11th hour. And so it's really important that this data is kept track of and kept up to date, particularly when we're talking about existing buildings. You know, you can have the best data in the world, structured right and everything, but you know, the older it gets, the more of a question mark is placed over it. And things happen in buildings, you know, renovations, damage, all sorts of things that change the way the building is. So we're going to talk about fire stopping. I wanted to quickly touch on what else is this applicable for. So health and safety wise, we've got PAS 1192 Part 6, which I think is due to be replaced later this year. But that's all about structuring health and safety risk information as per like the CDM process. Just adding a bit more structure to how that might be done within a BIM model. And so it's about taking risks, putting in mitigations against them, and then calculating the residual risk within that, and then keeping that in the model throughout the life cycle. Within there, environmental. So we've been working with our environmental team recently, and I can naively say that I did at one point think that most of the environmental stuff in terms of embodied energy was just putting a flat number against model elements, and through working with the team, I've worked out that environmental product declarations make that a whole bigger world and a bigger piece. But if we structure this data correctly in terms of energy use and recycling as well, then we can better swap the products out and make different choices. And that's all what it's about, making different choices and decisions. And we're going to be talking about fire safety later on, and chiefly among that is fire stopping in this presentation anyway. So a bit of an overview. This stuff running down the left-hand side of the screen, things that doesn't happen within Solibri and are probably prerequisites to what you'd want from the process. And so a good EIR is paramount. The EIR is a resource that says what information is required for somebody to do their job. So typically these come from, most commonly they come from a client, but it definitely doesn't have to be from a client. So when we're working on a project where we've got no involvement other than this sort of fire stopping check, then we have a list of things that we need from the models, and that's included within our exchange information requirements. We need to move away from unstructured data. So, you know, things like specifications, documents, anything in like a long PDF might have some great content in there, but it's really difficult to check that and to actually use it. I think as an industry, we're very focused on structuring information how we, the author, want to produce it, rather than thinking about how the end user can use it, and even like how sort of a machine can interpret it as well to actually use some of the data. And within Solibri, we're essentially checking this data through the rules that I'll talk about, and then Simon will give a live demo with. And we also look at it visually through classifications, and a key one for clients is these takeoffs, where you can schedule out all of the fire stops within the model for other purposes. And then we can produce outputs through dashboards and reports, and these are key for to affect decision making of what needs to change. We can do everything on the right hand side with Solibri. So let's talk about fire stopping a little bit. It's typically something which is sort of in a scope gap on a lot of projects. It's something that it's a hot potato that nobody wants to touch, and it's something that we see, BIM or not, doesn't happen particularly well through the design, let alone when it gets to site and the rest of the lark. So that's the key sort of reason of why we do these checks within there. That's that scope gap. So going to go through a bit of terminology. So this is a builder's work opening. So credit to Rockwool for the image that we've pinched with permission. So the blue box around it is an opening through a wall. We call this a builder's work opening. So it can be through a wall or a floor or anything else really. And these are put within information models to show where a service needs to go through something that it can't do without somebody making an opening. And then within it, we can put a fire stop, so this can fill the whole opening, or it might be sleeved around the individual elements, or sprayed, or there's other ways of doing it. But it's basically a product that you'd put in there to stop the spread from one room to another, hence the name Firestop. As a wall will be made to a particular sort of minute fire rating, and then somebody might go punch a hole through that wall to fit their service in. So product needs to go around it, otherwise it can cause issues. When we talk about service penetration, these are just things going through the opening or the fire stop. So we've got some cable trays and some pipes there, could also be ducts and other things. And then service spacing is the distance between the pipes or the services, and then the aperture spacing is the distance between the service and the edge of the opening. So digital approach. We don't really see this as like a one-time search. You know, it's not like, oh, get the models, identify all the issues, it's all fixed. It's an iterative process, much like coordination checks are anyway. It's kind of a broadening of the definition to include fire stopping within that. So, you know, it'd be about checking, providing feedback, you know, seeing that, you know, some of the issues are mitigated within the models, repeating it, checking on site, all of this sort of stuff is important. It's not a push button thing that solves things. And we're using Solibri to do these checks, and BIMtrack, although you could use a different sort of BCF platform than BIMtrack, but I think Solibri is key in that. Who's this relevant for? I'm tight on time, so I'm going to summarize this slide and say everyone. You know, as a contractor or a designer, it's going to mitigate risk by doing it properly. And as an occupant, we all benefit from safer buildings for obvious reasons. What data is needed? So the sort of prerequisites to what might be required within your information model before you can do the checks that Simon will show. So we need all elements to be assigned an IFC class, and this just means that when you click on something within a model, it's going to know whether it's a door or a window or a pipe or a cable tray, and IFC is the standard and schema that we'd use to do that. And most importantly, in IFC, you've got different enumerations, so that instead of it just being a cable carrier, you can tell it whether it's a piece of trunking, or it's the cable tray, or it's a cable ladder, as some different manufacturer specifications do deal with those differently. We also need material data, so whether it's a copper pipe, a plastic pipe, or a steel pipe will change how the rules should work and how manufacturers need the services spaced. We need fire rating information within the walls and floors and doors as well. And the key one here is that a lot of the time this data exists already, it's just not within the structure that we need it to be. So you don't come across many projects where there's no fire strategy drawings, but the common misconception is that they're structuring 2D information differently to how the 3D information is being produced. So either the information is not going in the right place, or it's not the right format, or you've got some you know, terrible producing drawings and a model practice going on. But it's key that any 2D or unstructured deliverables are matching what's going on in the model, and you've got that single source of truth. Nominating products and narrowing down that list is really important. So on the left hand side there, you can see just a few Firestop product manufacturers, and within that they've got a huge range of products that they will use, and we build the rules off of when we're checking. It's easy to build them off of a shortlisted list of those products that might actually be used. And when designers are designing, they kind of need to know some basic rules of distances anyway, so that, you know, by the time we're checking it, we're just picking up on a few issues rather than every single opening in the project. But you can see from the right-hand side, there's a snippet of the Rockwool test data, and it's quite hard to digest. It's a long PDF, and so some of the work that Simon's been doing is to try and incorporate that into a spreadsheet so that you can compare different products and maybe have the option to swap out different products where a design change might be tricky. We need builders works and Firestops modeled. We've been doing it with these really basic boxes. You could go more detailed, but even just this box will give you a whole range of different checking options. You can do it without the box that you've got here in green and those teal ones on the top, but really you're just limited to surface spacings within fire rated walls and floors. You're not looking at distances between apertures and controlling the size of openings. So you do need those modeled in, but we see those quite typically on projects anyway. And then very lastly, if we talk about outputs, a key one for clients is that image sort of in the middle where you can see a schedule of fire stops that are within a project, and we could say whether they're compliant or not. You've got the image to actually see what it looks like. It's actually quite key, you know, BIM or not, on projects, that people don't actually know how many fire stops are needed, and that's key not just for the installation but also for the maintenance of those. So you can see the COBie spreadsheet below that. They could be put into the COBie spreadsheet, they could be put on a maintenance list, although they don't degrade over time as much as some other products, although everything does degrade over time. It's more about checking things to make sure that no changes have been made, no contractor's been there and, you know, destroyed some good design work. They're definitely things that need to be on a robust maintenance schedule. And linking to some of the things that David said, you know, if you have a list of fire stops in there, you can use that as a pro forma to all the way through to check that it's been installed properly, to then photograph that on an iPad to see if it's the same as in the design model, to then maintenance, you know, even taking a picture of that every year. You know, might be overkill for some of them, but there's nothing more important than checking this sort of stuff. Those sort of outputs. And that's the end of my presentation. I'll hand you over to Simon.
Thanks, Alex, and apologies for not giving you a proper introduction there. So this is a BIM manager at Region Partners, one of our customers, and has done a couple of presentations for us before. And actually what he hasn't told you there is that the work they were doing with the fire stopping, they've actually won a number of awards for. So it came to our attention, just the work they were doing with fire stopping, and that kind of sort of leads us into sort of the next presentation from Simon, where we've tried to take some of the work they've done and automate it a little bit more. Just before we move to Simon, now I know how to use the polls. I will share them and run the second poll. So first of all, just sharing personal. So that's the first question we asked. At what stage of the project do you do your fire safety coordination and check? So that's just showing you the results from that. Okay, and then if I just move to the next poll, who checks the digital model within your organization for compliance? I'll just launch that one. And if you can answer that, we'll then move on to the final presentation, which will actually be a live demonstration. So just let that run a little bit longer. Seems fairly even spread between BIM coordinators, design managers, external consultants. Some companies use internal fire specialists. Okay. That seems to be just slowing down a bit now, so I'll close that and just share those results. So you can see quite an even spread. So that's quite interesting, I think, with that. Okay. So next we've got Simon Gilbert, just about to show some of the automated fire checks that we have available in Solibri and some new developments that we've been working on. Simon has been providing BIM consultancy within AC companies for 25 years or more. Initially focused on the generation of geometry via authoring applications, both with Autodesk and then later with graphic software. He was the product manager. Since 2012, he's been at Solibri and has obviously moved from the authoring side more to where he's looking at the models that our customers are delivering and helping them achieve compliance and apply quality assurance to their projects. He continually strives to have an impact, a positive impact on the design, build and operation phases of a project, and his expertise and experience is helping ensure companies achieve their goals of checking both the geometry and the data for their projects. He was heavily involved with the Kobe developments in the UK as well. They always say don't do live demonstrations, but that's what Simon's going to do. So I'll hand you over to Simon. Just bear with me a second. All yours, Simon.
Thank you. Okay, let me know when you can see the screen, Andrew.
Yeah, we're fine.
Okay, brilliant. Thank you. Thank you, Andrew. And also thank you both to David and Alex for really informative sort of presentations there. What we're going to do now is just give you a bit of an insight, and then I'll do the demonstration within Solibri as far as what we've achieved so far with the help of Ridge and Partners and the other contractors that are involved with this development. So we're looking at the fire stopping of service penetrations, but before we do that, let me just move on to the first sort of slide, just to give you an introduction really. So from Solibri's point of view as a model checker, a lot of users start off with, opening models up, working with model-based workflows, doing the typical kind of clash detection type of rules in order to find sort of issues within buildings. But then obviously moving that along, Solibri gives you the ability to sort of refine the data within a model and create what's called custom rule sets. Now inside Solibri, we have somewhere in the region of about 60 odd rule templates. Those rule templates can be configured to create millions of different permutations in order to check different parts of the building. And then obviously if we need to report that, we'd report that through the issues themselves or through creating information takeoffs that can actually report that data. Obviously users then can move into sort of improving that functionality even further with creating ways to deploy those new rule sets, and also to automate the whole process of running those at any part of the day really. Now, what we have done is we've created a software development platform, and this is really key to the development that we're talking about today. It provides us with an application programming interface, which enables us to create new rule templates within Solibri. So use the wealth of over 20 years of functionality within the software and give us the ability to build on that and generate our own rules, which are more specific for the industry rather than more generic inside the box. So that's what we're currently looking at here, a very specific use of the technology. So we started off with looking at the fire stopping guidance for the Association for Specialist Fire Protection. And what we're looking at is the golden rule in here, which is the golden rule 3, which is all about the identification of service intersections with compartmentation walls and floors and what their key spatial requirements are for those services. And Alex gave you a few really nice images from Rockwell which give you the kind of dimensions and those types of things that are actually required within the model itself. So this is what we've done to date, and once we're happy with this data and it's at a point where it's robust and it's been tested fully, which has been happening as we move along with this development, then this will be released to our user base. So the first part is we have a fire stopping identity rule, and the identity rule enables us to identify all the service penetrations going through any compartmentation walls or floors. Now, we've done quite a lot of work here where objects may be present, panelized systems where voids are not present. So basically, we will find the intersections between physical components like walls and surfaces. We'll also find the intersections between voids, say openings, and where those voids aren't present, so it isn't a physical clash, it will still find that data. And then what we can do then with this fire stopping identity rule is we can allocate basically, or to check how many of those services have been addressed by a BWIC or a fire seal component, and we'll have a look at that in a second. Then we have the fire stopping distance rule, and the distance rule is really all about checking the physical dimensions related to the fire seal or the BWIC in this case here, so it can actually start off with the BWIC if you want to. But we have a setting in this rule, which is basically if we set it to off, then we can do some very early generic distance checks between services. It's driven by an Excel spreadsheet in the background, and that gives us the ability to just give you some kind of rules of thumb sort of checks between those services to highlight problems that you might have before you get into planning of those items. Then when we turn the option on with that within the same rule, we can then check the distances between those fire seals or the BWICs themselves. And again, that's driven by a fire seal distance tab. And you can see the image there is pointing out the distances between them. We can also then check between the fire seal edges and the surfaces to make sure they're meeting their requirements for those services and the instance of the fire seal itself. We can check the allowed services within certain types of fire seals, so that we're not putting services that shouldn't be actually placed in those particular fire seals in there. And we can also make sure that we've not got any partial sort of penetrations of those fire seals. So making sure that the services fully penetrate right through the middle of those components. And then we can check the services distance within the fire seal against the same service or different services. And again, we've got a tab in the spreadsheet that will do that as well. On top of that, we have another rule which checks the dimensions of those fire seals in relationship to information that you might get from a manufacturer. Just checking that the actual dimensions of them are compliant. And then also that we're checking for the positions of those within the walls. We're checking here for things like drop head details, where certain instances of these seals can't be placed in certain conditions. And we're picking to the edge of the walls, things like that, which we can actually configure as well. So quite a lot of work gone on there in order to achieve those goals. We then can check within the same rule here that the fire seal fits the BWIC completely 100%, i.e. that there's no gaps between the builder's work hole and the actual fire seal itself. And you can see with all our reports there in the description part within the dialog box, we give good quality descriptions as far as why it's unsatisfied or it's failing and what the actual requirements would actually be as far as those distances, as you can see. We've got some remaining development here to do, which we're currently working on. We've got the service distance measurement adjustment, because we should be measuring between any fire stopping products, not particularly just the services. So if we have sleeves that go around UV PVC pipes, then it needs to measure to the seal dimensions. And also the accessibility of those. So not only checking the locality of those BWICs or the fire seals within the wall itself, but also making sure that we can physically install those and maintain them correctly as the building sort of matures. We've also then will check the supporting construction. Again, checking whether the installation whether it's single or double-sided for the installation, and then comparing the manufacturer's requirements of that fire seal against the wall data or the supporting wall or floor supporting construction. That involves the thicknesses of the floors, the type of construction, the the acoustic rating, the fire rating, all those kind of properties that are required from it. We've had requirements already from customers that are looking at net gross areas for the materials for these services, as far as for installation and optimization of materiality. And then finally, once we've done that, we will collect all this information and create an output thread for the fire seals and service information to help with that golden thread information within the model. And then we may do some cleaning up of the rules and how they're aligned and how it generates the data in the background once we're happy with the way they're all working. So basically what we'll do is move over to the demonstration now. So we'll come out of PowerPoint and we'll go over to Solibri. I'd just like to thank, first of all, obviously this whole development was really based upon, we saw the great presentation on a customer insights demonstration from Ridge & Partners. We reached out to them and we created a group of like-minded bodies, number of contractors as well. And I'd like to thank particularly Lango Rock here, where they've been pushing me every week to try and improve some of the functionality here. So what we're looking at here is just a very sample model, which has a number of services in it. What I'd like to just point out is that we have a couple of classifications. Solibri uses classifications to group elements in order then, and group and color code elements basically to create baskets of data. So in this case here, they're not necessarily, we wouldn't necessarily call these fire seals. So what we actually have is the seals in the model. They might be the IDs of the standard details from people like Rockwall or Hilti or anybody else. And that would give us an identification for the type of seal, not the instance, because that would be the ID. And then we would then have a grouping of different services. And again, it wouldn't be this low level. It would be broken down to maybe small, medium and large pipes, or whatever, UPVC pipes, copper pipes. It could be actually right down to the granularity of the exact sizes that might be needed to test against these seal conditions. So the idea here is that we're grouping and analyzing that data in order that we can drive it into the rules that we've currently got. Now, when we move over to the checking area here, we've got these rules that I've just gone through in the presentation. If we hit the check model button here, it runs through those checks. And the first thing is that like we specified in the presentation, was to check the fire stopping identity rule. Now, the identity rule here breaks down the number of walls where we have services going through those compartmentation walls. And in this case here, so we'd have to identify which are compartmentation walls first of all and floors. But each one of them is then treated. And in this case here, if we open up this wall 1.6 here, you'll see on the screen that we can see the number. We've got 16 penetrations through these are the services. And we can see as we then go through these, that it's actually listing them in order and in the position within the wall itself. So what we wanted to be able to do here is use this as an identification sort of tool, but also it might mean that you're selecting these and we're not selecting them from the top to the bottom. We're doing it based upon order. So you can then start planning your BWICs basically and allocating sort of allocating the movement or the progression of what we need to do for these particular services. Now, once we've done that and we've allocated BWICs to them, or we've started creating fire seal elements, we can also run a version of the rule which will then check the same set of data. But in this case here, you can see our 16 here, and in our 16 you can also see these light blue objects, which are our fire seal objects or our BWICs, if you want to classify them as those. And what it's showing us here is that for each of these, there is a fire seal component here that's around it. As I say, it could be, you could actually do it at an earlier stage and just actually classify these as BWICs. Now at this point here, it's saying this component doesn't actually have them. So these ones could be accepted. This one here needs to be addressed because it doesn't have it doesn't actually have a fire seal actually allocated. So this is really just to ensure all the time these are run. There's no additional services that haven't been addressed at any point in time throughout the project, and that at least we're so I expect these to be run on a regular basis across the project itself. And then we can move into sort of the fire stopping distance rule. Now, these two rules here, it's the same rule, the identity rule. they don't use anything to do with the spreadsheet. The next rules here that we're looking at here are driven by the spreadsheet for the data. So the fire stopping distance rule here, when we have an option turned off for it, so we're not using any of the fire seal data, what that does in the background is it uses a spreadsheet, and you can see the number of tabs we've got down the bottom here. So what we're looking at here is a service distance sort of check, and what we're doing here is we're listing the service types that come from the classification you just saw, and then we're saying what the distance is between the same service and a different service. So this is more a case of just doing a very outline quick check as far as the distances between those elements, and that drives the rule and then gives us the ability then to dictate and find those distances between those different services. So you can see here it's measuring between those services whether or not we would have a problem. You can see we've got 291 millimeters between these, and it will just go through each of those different services and actually find what the distances are, so we can actually start tracking whether there would be a problem or not. Again, very rudimentary outline sort of rule. But then when we turn the options on to deal with the fire seals, then what we can do then is use the other tabs here. So we can look at the fire seal distances, and again, we can have the IDs of the standard details here for the different fire seals. And then we can specify the distance between those fire seals. Now we've also added a category function, which means you can name your results how you want to see them, and that's the idea behind having the category there. So you could actually have manufacturer approved, or you could have just in this case here, I'm just calling it fire seal distance. We also have then the fire seal and service distances. So what this is doing is saying between these different types of standard details, these are the allowed services that are in here, and this is the distance to the edges of the fire seal. And you can see here we can also state the type of services that are allowed in here. So in this case here, for fire seal 3 with an example here, we were only allowing pipes through that one fire seal, and we're calling this service to aperture sort of a check. And then we've got the service distance within the fire seal. So again here we can then put the source service type here and the target service type, and then we can then put the distances between them again, and we've now got the fire seal service to service check. So what that's doing in the background here is that you can see the fire seal distance check. So this is now checking off that second tab, and we can now see that it's now checking the distances between the actual fire seals themselves. And again, this would work if these fire seals were defined as BWICs as well. Just depends what stage you're actually at the project, whether the component's actually placed in. And again, we're just measuring between these components. You can also see that where we have the incorrect services, so we said that only pipes were allowed within this particular service, you can see it highlights it to us and tells us that basically these services are not allowed in this fire seal, which was fire seal 3 in this case. On top of that, then we've got our distances to the apertures, and you can see that here where we are requiring a certain distance, in this case here, these cable carriers, these cable trays, you can see that we've got 25 mil here. The results in the description will give us good quality results. So in this case here, it's telling us that this is the ID of the seal. So we'll give you an ability to put an ID in for each seal. This is the actual, say, the manufacturer's sort of standard detail or the type of fire seal it is. And then we're saying this cable carrier requires 50 mil, but we've actually only got 25 here. And the same goes for this instance of it here. So when we're creating our issues and we want to then generate any data from that, all we have to do is create the slide, and it's pushing the data into this as far as all the information and the fact it's not satisfied and what sizes we've got into the actual data we need for the issue itself. And again, this one's at 27.5 in this case. We also can check that they are actually completely contained within the actual, and you can see here, these are all fire dampers that are slightly, because they've got the flange on the outside of the wall in this case here, we're just checking to see whether they're completely covered by the blue object in this case here, which is the fire seal. And you can see in this case here, it's slightly bigger and it's sitting on the outside, and we've got this control mechanism that's there. So the idea really is that we've got these rules that will enable us to check all those distances. We've also got the fire stopping dimension rule, which we discussed, where now we can actually put in the requirements for the dimensions. And again, this is doing this based upon the fire seal dimensions here, where we can put in minimum widths and maximum widths and minimum heights and maximum heights for each fire seal type. What that does is then highlights basically where we have an issue where it doesn't conform to what the manufacturers would actually suggest as far as for that type of fire seal, just in making sure we're not spanning too great a distance in that case. And then finally, just to sort of to finish this off, we've also got the fire stopping position rule. So this is not the one we talked about from an installation and access point of view. This is actually what the regulatory sort of requirements are for these fire seals within the wall or the floor itself. So what we're doing now is checking the positions of them within that, within the position within the wall. So in this case here, if we're saying there's got to be 300 millimeters between the edge of the fire seal and any, say, intermediary walls here, we can see it's failed because we've got 81 mil between those. Again, if we go down to, let's just go down to this one here, you can see even to the edges of the walls, it's tracking that. So we can also add a head distance to that. So if we go to our this one, positioning walls, you can see that we can set up our side conditions with an offset, so that we can check whether there's any components that are away from the wall, which also might cause a problem. The top compartmentation, so if we're checking for drop head details, we can do that. We're also with a maximum value there as well, and checking on offsets. And we can also define which components are obviously allowed within that area or not within the rule itself. And again, within the bottom compartmentations as well. And we can then label that however we want to label it for those fire seal positions. So that's checking those. And then finally, we are checking the making sure that any fire seal that's there is actually touching the builder's work hole perfectly. So in this case here, you can see there's a physical overlap here, but if there's a millimeter between it, it would still fail, kind of thing. So this one doesn't have a builder's work hole around it. So these are fire seals that don't have builder's work holes. This one's obviously sitting within it. But if we're checking that the actual edges actually perform perfectly between the fire seals and the actual apertures that have been created. And then we'll continue working on those other rules as far as checking the fire seals against the actual supporting construction, and then doing the reports as we said. So that's what we've worked on. We're hugely excited with trying to get this finished and get it to our customers so they can start using it in anger on their projects. But thank you very much for the opportunity to show it.
Thanks, Simon. No problems with the live demo, which is always good. Okay, there are a few questions coming through. While you're on there, Simon, I'll just ask you one that you can probably answer if I can find it again. What IFC category do you model the BW infill?
It actually doesn't matter what category it actually is, as long as you can identify those either by a filter, which is it could be by type, or it could be by the component element. What we suggest is really that you create a classification, you classify them. So as long as you can identify them in the model, it doesn't really matter what IFC component they actually are.
Okay, thanks. A few comments from Adrian Schilder, I guess. It's important to note that the golden thread should be based on providing information as part of compliance with a host of other standards and regulations, and the golden thread is one single isolated thing. Yes, of course, Adrian, completely agree with that. And I think obviously David touched on some of the other standards that they're looking at, and we know when we're working through these compliance regulations that there's lots of different standards to take into account. Let's just try and pick a couple of other questions out of there. Somebody asking where they can download Solibri to have a look at this. Well, you can get that from our website. The rules that Simon has showed won't necessarily be available as part of the trial, but if you contact us, then perhaps we can arrange that as well. Another question for you, Simon, I think. Why are walls checked in the first step and not just the ones who have a fire rating parameter?
Sorry, Andrew, can you repeat that? Why are walls?
Yeah, why are all walls checked in the first step and not just the ones who have a fire rating parameter?
They're not. So basically the rule initially checks only fire compartmentation, walls and floors. That's the whole idea of the fire stopping functionality. So as a user, we highlight, or you have to again sort of specify which are the walls that you are, the compartmentation walls that we're checking them against. And throughout all of that, it is checking exactly those walls and those services. So even though the first rule that you saw, which was all about the identification rule, that rule basically is carried through to all the others, because we have to check so when we're checking all of those distances, we're not just checking the distances to the aperture of the fire seals or the BWICs, we're checking it only in the locality of where it intersects with the walls. So it's a little bit more intelligent than just a sort of distance checks that we're actually carrying out. It only happens where those intersections are. So they have to be part of those rules as well. So they are a fundamental part of the whole set of rules, the compartmentation, floors and walls and floors.
Okay, thanks, Sam. There's quite a lot of questions coming through. I'm very aware that we've kind of used up our time at the moment, so we will get back to people afterwards. A couple of people commenting that we've missed the lead designer off the poll. I apologise for that. That was my fault when I was rushing doing those this morning. Also, a couple of people asking whether the slides and the presentation will be available. That will be on our website, I guess, within the next day or two, I would think. So you'll be able to watch that again from there. Okay, I'd like to thank all our speakers. David, thank you very much for your time. Was great to hear the overview from a government point of view, and delighted that you could join us. Alex, once again, thanks for your time and your presentation, and we look forward to looking closely with you on the development of the rules as we go forward. There are people asking when the rules will be available. We hope to issue some of them very soon. Just watch this space. We'll send out information once they're available, and hopefully we can get some more feedback. But with that, I'll end the broadcast. Thank you for your time. Please remember, we do have webinars every month. Our customer insights, so we hear from our customers about extraordinary things they're doing with Solibri. So please join them and learn from them as well. Thank you very much.
Thanks, Andrew.